Let us recap what we have. Why do we need to do logarithm? Okay, while I meet some of the students. Okay, if you take a look at the top two questions, one is 3 to the power x is equal to 27. So IT, if I want to do this question, what will you do, IT? 3 to the power x is equal to 27.
I change 27 to 3 to the power of 3.
Very good. Because it can be changed to base 3. So in other words, your x over here will be equal to
3.
3. Okay, but IT, I ask you, the one on the right side, do you have the ability to change 10 to 3 to the power of something?
No.
Then what will you do?
This question I'm not sure, but I learned them.
You take ln, is it? Okay, it's
Yeah.
okay. Ln is also a form of logarithm. You want to take log to base 10, you want to take ln, both are possible. Okay, so IT say take ln, so I put ln is equal to ln 10. Then IT, what's next?
Move the x in front.
The power, you make use of the power rule, right? Okay, the x can be brought forward. Ln 3 is equal to ln 10. Then how do we find x?
Ln 10 divided by ln 3.
Okay, very good. Ln 10 divided by ln 3. If you press your calculator, what will you get?
Yeah, I haven't pressed. 2.09.
Okay, that's the introduction to logarithm. Okay, so this is simple, but one thing you need to know, okay, there are two ways to okay, all right, A is the base term, all right. What do you call C? Renan? What do you call C?
What's C?
C is known as what term? Start with I.
C is the power, A index.
The power is also known as the index term, all right? This is the main term. So if I want to change logarithmic form back to index form, all right, always write down the main term is equal to the base term to the power of the index. Okay, so the main term stay, the base term to the power of the index. Okay, which is what Renan told us, it can be power or can call index. Similarly, in ln, okay, ln can be written as log to base e. So Renan, can you tell me how to change this to index form? Renan, which one stay?
X equals e to the power of y.
Okay, thank you very much. Okay, so I've covered two. First, on top, what I covered just now is, if I cannot find and solve the unknown, I introduce the log and the log yourself. Next, if the ln and the log is given to you, I need to change back to index form. All right, I will need to do this. Okay, main term will stay, base term to the power term. All right, that's the introduction to logarithm. Please take note, these are the three laws of logarithm. The first one is the addition rule, but for you to apply, the base must be the same. Then you can combine the main term by multiplying the main term together. Likewise, all right? This one is subtraction of two log terms with the same base. You can combine the main term together by doing a division. Like what we see earlier on, all right? When there is a power, okay, you can bring it forward in front. Okay, these are the three laws of logarithm. Okay, the one in red. So they mean the same thing. Not that we have to always use it, but you need to be familiar with it. But the most important thing I want to go through is change of base. When do we need to do the change of base? Is when in a question there are too many logarithms. I must change to a common logarithm. Okay, so I usually try to change it to the smaller number. All right, I usually try to change it to a smaller number. Okay, so in this case, if I have log b to base a, I don't want base a. Let's say I want to change to base c. What is very important if I want to change to base c? Karina, if I want to change this question to base C, what must I do?
Change to base what?
Base C for cat.
C.
C. What do you do first?
Write the original and then over the new one, or is it the
Write the what? Okay, most importantly, you must draw what first? You must draw something. What's that something? The fraction line, right?
yeah.
Then what do you write? You must write log to base C, log to base C, because this is the one I want to change to. Okay, what is the main term on top? No. Okay, the original main term always go on top, B. So the original base term will always go below A. Alright, this one is higher, go on top. This one is lower, go below. Okay, try another one, Karina. What if I don't want log to base E? I actually, base C, I want ln. I write ln. What to put on top?
E, then B over A.
B over A, this way. Am I right?
Yeah.
Okay, this is for change of base. Change of base is very important. There is always one question on change of base. Alright? So, Zishun, how will you get started with 2A? Zishun.
Yes.
How will you do 2A? Can you do logarithm? Just log on both sides?
No.
Why cannot?
Cause not sure. Don't know.
Okay, you are correct. You cannot use log because you see, you want to use log on each side must have one term. Look at 2A. 2A has how many terms on the left side?
2.
So I cannot use logarithm. Logarithm can only be used when I have each side got one term each, like what we see earlier on. So, Zishun, if I cannot use logarithm, am I stuck?
Yes.
So when you are stuck, I must use the substitution method. So what substitution method do you think you will use?
4T.
Wait,
No.
you are not wrong.
No.
Okay, 4T. You want 4T? Confirm?
No.
Why no?
Wait.
Look here. There is a 4 here. There is a 2 here. Which number is smaller?
2.
So we always go by the smaller one. Okay? So it must be 2 to the power of t. Do you agree? But the one is 4 to the power of t. How?
2 to
Okay, I agree with Zishun. Because you compare, I want to use substitution method. I try to use the smaller number. I don't use the bigger number. Not say cannot, alright? But it's always easier to deal with the smaller number. So Zishun, what's next?
bring the 2 outside.
Which 2 bring outside?
The power 2.
Power 2 bring outside. Okay, can. So 2t, like that.
Wait, is it?
Is it like that?
Yeah, I think.
Then how about the one on the left side? How about the one on the left side? Okay, so Xingfai is correct. You see, Zishun told us is 2 to the power of t, so he wrote the square on the outside. Can. Then Xingfai also said, oh, the plus over here can be written as a multiply. Very good. Okay, do I have 2 to the power of t or in terms of 2 to the power of t already? Yes. Then I use substitution method. Let A be equal to 2 to the power of t. Alright? Then you realize 2a to the power of 4 plus 5a squared minus 3 is equal to 0. Alright? There is a square, there is a square. So I can do my factorization, then I can use my zero product. Alright? If you were to do your factorization, this is what you get. 2a squared minus 1, a squared plus 3. Alright? So, I will go and do my zero product rule. So this means that 2a squared is equal to 1, A must be equal to half. Correct? A square equal to half. So A must be equal to, okay, wait, let me, so you see, I use zero product rule, I split, A will be equal to half or A equal negative half. Again, my job is not to find A, all right? My job is to find 2 to the power of t. 2 to the power of t equal to half, 2 to the power of t equal to negative half. Can 2 to the power of t be equal to negative half? Cannot. 2 to any power number will always get positive number. A, this is NA again. So our job is to solve 2 to the power of t. Oh, 2 to the power of t equal half. Can anyone tell me how to solve for t now? Aravind? Half can be written as 2 to the power of. Bring the 2 up, becomes 2 to the power of.
-2.
Huh? This is 2 to the power of 1. Bring it out, it becomes a 2 to the power of.
-1.
So t will give us -1. Alright? That goes our first question. Alright? This is substitution method. Alright? Okay, some of you could be completing 2b. So I'll roughly go through with your 2b. Alright? 2b is very straightforward. Why? Because it's a single term on each side. There is a power. The base, I cannot make it the same. I cannot make it base 6. I cannot make it base 5. So I take logarithm on both sides. After that, use the power rule. Bring down the power. Remember, I write a bracket. Then I make P the subject. Notice I don't go and press the calculator at the very first step. I express everything in terms of P. Then at the very last step, I press the calculator because I don't want to keep writing the decimal. Alright? Starting in 2C, can we straight away use logarithm? Can we use logarithm immediately in 2C?
No,
Why cannot?
because we got 3 terms in one side and no terms
Okay.
on the
So
other
we have
side.
3 terms on one side, but the other side only have 1 term. Logarithm must be 1 term on each side. Okay, so Sati, what do you think you need to do in 2C?
Expand first.
How to expand? Look, there's a 10 to the power of y, there's a 100 to the power of y. We should change to what? Sati?
2 times 10 to the power of 2y.
Okay, very good. 10 to the power of 2y minus 10 to the power of y minus 6. Because we must change the one with the smaller one, so base 10. But I don't want 10 to the power of 2y. Sati, how to rewrite?
10 to the power of y times 2. Sorry.
No, not times 2,
and square.
power 2. Sati, we are at that juncture, stuck, cannot do anything. Whenever we are stuck, what must we do?
Substitute.
So I let b, in this case I just change, substitute. 2b squared minus b minus 6 is equal to 0. Your job is to not to, okay, of course you can do your factorization. Okay, do a quick one. You can press the calculator as well. So if I were to factorize, or you press a calculator, what are the 2 values for b, Sati?
2
And?
negative 1.5.
But is our job done?
Not yet.
Not yet. Why? Because our job is not to find b. Our job is to find y in this question. So let me rewrite. Sati, let us do this part first. 10 to the power of y is equal to negative 1.5. Can this be solved?
No.
Why no?
Actually,
Okay, don't worry. If you cannot, you can always use log. Because 10, this is base 10. Negative 1.5 cannot have base 10, right? So you use log on both sides. Can you log a negative value? Cannot. That is why this is NA. All right, because we cannot log a negative value. Whereas on the left-hand side, you can. Let me log. All right, bring down the power y. What do you realize? Log 10 to base 10 is actually 1. So, in other words, your answer here is just log 2, but press a calculator for log 2. Don't leave it as log 2. Sati, when you press calculator, what do you get?
0.301.
Okay, thank you very much, Sati. All right, then we are done.
Okay.
Okay, part D is the logarithmic question. One look at this question. What do you notice about this question first? Anyone can tell me what is very obvious in this question? Can anyone tell me what is obvious?
Same base.
Very good. Anqi, the base are the same. So Anqi, can you tell me what you will do on the left-hand side over here since the base are the same?
Log 4x plus 8 over x minus 4.
Very good. We use the subtraction rule. X plus 8 over x minus 4. Anqi, I don't want the 2 on in front. What can you do?
Move it up.
As a power, right? Okay. So I move it up as a power. Okay, everyone take note. Can you see, observe, this one and this one, they have the same base. Alright? And there's only one term inside. So in other words, since the log are the same on both sides, I just have to compare the main term. So x plus 8, x minus 4 will give us 3 to the power of 2, which is 9. So just have to solve. And then you press a calculator, you should get 5.5. What I did in part D, I just used what Anqi told us. Oh, the base are the same. I combine them into a single base term. If you tell me, teacher, can I move the term on the right hand side to the left hand side? You can. But this is a shorter method. If you want to move the term from the right hand side to the left hand side, I'm also going to show you right now. What happened is, I can do this as well. Teacher, can I do this? Yes, you can. Take a look. So this one combined already. Oh, what if it's like that? Because if I move, this is still subtraction of 2 log terms. So I need to divide by 9. So I can do this. I have to divide by 9. So x minus 4. Then I can use my logarithmic function, change back to the index function, like what Brandon said just now. Write down the main term. Then the base term to the index term, or to the power, which is equal to 1. If you do your cross multiplication, you still get back the same answer as what I did earlier on with Anqi's method. Alright? Okay, if I take a look at 2e, what would you need to do first? Very important. You must do something first. What is that something? Sherilyn?
Move the log term there.
Very good. You balance all the log term to one side. So I'm going to write that. Very good. So I book all the log term to the left hand side. The number need to do so or not?
Don't need, just leave it there.
Leave it there on the right side. Then what do you need to do to a 2 log term? I combine them together, right?
Yes.
Okay. So I use the approach that Anqi said just now. This is subtraction. I'll just do a quick one. Okay. Now you see on the left side is the logarithmic term. On the right side is a number. So what should we do next, Vidya? I have a single number on the left side. I have a number on the right side. So Vidya, what will you do? So I've done everything for you already.
Mr. Liu.
Yes?
It's 2x minus 2.
2x minus 2. Thank you. Vidya, I have done everything for you, no? Your job is to find x, but I cannot deal with logarithmic terms. So, Vidya, what must we do? The one that we asked at the start of the lesson.
2x minus 2 over 4x minus 9 equals to 2 to the power 3.
Yes, all right. The main term will stay, all right? This is the base term, right? The base term to the index term, all right? After that, you can solve accordingly. Okay, do your cross multiplication. I'm just going to do a quick one, huh? Okay, so what Sherilyn did was correct. In logarithm, you must balance all the log terms to one side. If there's a number, let the number stay. Once you combine into a single log term, all right, this is what I call a single log term. The next thing is to change it to index form, all right, like what Vidya did for us. So this is very important because there will always be some basic question like this, all right? Kokai is correct, huh? The base in 2f are not the same. There is a base 3, there is a base 27. For such case, we need to change the base. Which base do we change to? 3 or 27, Kokai?
I three.
Why 3?
Easier.
Why easier?
Lower number.
Change to the smaller number. The guide is to always change the base to a smaller number, all right? Always change to the smaller base. Okay. Okay, I believe you all are following what Kokai is doing, all right? We need to change the base 27 to base 3. So like what was said earlier on, we need to write a fraction. Okay, like what Karina did. The main term will stay, x will stay, 27 below. But don't keep the 27. 27 is a special number. It can be written as 3 to the power of 3. Then after that, very importantly, take note, I use the power rule to bring in front. That's why I bring down the 3. Oh, now, what's the end result of log 3 to base 3? This one you should know by now. You should get a 1. So in other words, it's 3 times 1 over 3. Okay, come to this step. I need everyone to be very alert. Can you look at the screen now? Okay, just look at the screen. Okay, come to the step in red color. How do we solve? Teacher, got 2 log terms. How to put them together? There are a few methods. In fact, there are 2 main methods. Okay, Sati said the number 3 at the fraction is obstructing us. So, he multiplied by 3 throughout. So, Kifi, you realize your test last week, there was a common error. You multiply by, you forgot the right hand side. So, if I multiply by 3, this is what you get. Teacher, how to combine? Take note. There is a number 1 here. 6 of log x to base 3 minus 1 of log x to base 3. How many is left? 6 minus 1 means I'm left with only 5. Then what should we do next? Hilfi?
Divide by 5.
Divide by 5. Very good. After that?
Then index form.
How to change to index form?
X equals 3 to the power of 3 to the power of 6.
Okay, can you help me press the calculator? What will you get?
729.
729. Okay, this is Sati's method. Because Sati said multiply by 3 throughout. Is the logarithmic term the same? They are the same. Yes.
I wrote cube root x to the power of 5 is equal to 3 to the power of 10.
Cube root x to the power of 5 is 3 to the power of 10.
Then right, I made x to the power of 5 equal to 3 to the power of 30. Then
Also can.
X is
Ah,
729.
you do step by step. Yes, you are correct. Okay, also very long. So I want to do a shorter method because you are killing yourself over the index. I don't want. Look here, shorter one. Okay, don't blink. What is 2 minus 1/3? 5/3, right? What is killing Priya is she went to bring up the power, but I don't do that. Don't bring up the power. 10 can be divided by 5/3. What is 10 divided by 5/3? You can press the calculator, 6. So after that, you can straight away do your index form. Okay? Don't always think of bringing up the power. If you can divide by the number, it will be easier for you. Alright? So if you ask me, out of the 3 methods, okay, I don't mind the first method in red. The method in black that Priya recommend us, you must be very good with your indices. Okay? The one in orange to me is the easiest, it's the fastest.